And I'm looking for the answer. I got look for power. I think I see some hands going up. Yes?
6.
6?
No.
Close. Robert? 7. Robert, tell us fast why.
Is 2 to the power of 7 is 128.
That's all in the world it is. That's why the answer is 7. You go back to middle school, 2 raised to the 7th, 2 times 2 times 2 about 7 times is 128. Written in this new form tonight with us, logs, that's what it looks like. I'm going to throw one more at you. A log. I'll actually do this. I'll give you an interesting one. I come up with one. Yeah, let's do this. 1/4 is a base. Oh my goodness. Oh, let's try 128. Oh boy, I know it wasn't going to be possible. I threw that together real fast. I think it might be possible. If anyone thinks they have an answer, we'll look at it. Log of 128, this time base 1/4. Yes.
Is it -8?
Come again.
-8?
-8. Hang on now. David, if you say -8, you're telling me this should be true. 1/4 raised to a -8 should be 128. No, I see what you're saying. And now you're saying 1/4 raised to a -8, that negative sign says flip that over, so it's 4 raised to the 8th. Another way to think of it. Wow. Is 4 times 4 times 4 times 4, David, out 8 times, you think they'll give me 128 or something bigger?
Way over.
Way over? So it's not that.
That would be -6.
-6, hang on. Lisa, if it is, put a 6 in there. Now this becomes 4 raised to the 6th. 4 times 4 times 4 times 4 times 4 out 6 times. If that will give me 128, I'm happy. Guys, will that give me 128? 4 times 4 times 4 out 6 times? No, I see some heads shaking. Samantha,
Yeah.
what do you have any idea? I saw your hand going up. 3? -3. Hang on. If it is, in this case, it looks like this. That says 4 times 4 times 4, that's 64. I want 128, which you're very close to. Robert?
-3.5.
-3? Oh, -3.5. Hold on. What? Who says professor is that? Oh my goodness, I threw this out there. I'm gonna check it, Robert. Mr. Mathematician back there. By the way, he gave me 1/4 raised to a -7/2, guys. I'm gonna flip that over and make that 4 raised to a +7/2. That looks better. That's all because of that negative sign there. Do a reciprocal, flip it over, 7/2. And this, guys, 4 raised to a 7/2 translates into 2 means square root of 4. That's the 2. Raised to a power of what? 7. Robert, here goes. Square root 4 is 2. Is 2 to the 7th, 128. 2 times 2 times 2 out 7 times, boy, you get 128. Answer was -7/2. You said, Professor, can I just meet you if I see you? Which I'll probably just wave at you and move on before you get to me, because I know you're going to ask me this. And And I know if I'm with a group of my little friends, I don't care, I'll embarrass you. I'll ask them also. I'll ask them, give you a good log problem. No. It takes a little thinking on some of these as they get tougher. So we gotta come up with some little system here. Yes?
So how are we expected to know that 7 halves is gonna be what's gonna help us find? We're just gonna have to know.
Robert, give it to me. I will. Whoa. Where am I? Oh, down here. It means this, and watch what I'm gonna do. Glad you brought this up. If Robert, he may in his mind been doing the same thing, we had 1/4 raised to a negative 7 halves is equal to 1/28. Is that what we had over here? Right? Now watch what I'm gonna do, and I'm gonna do more of this later on. Guys, I'm gonna rewrite 1/4 and 1/28 like this. 1/4 I'm gonna rewrite as 2 raised to a negative 2. And we'll write 1/28 as 2 raised to the 7th. I'm gonna get everything in terms of 2. Just to confirm something. If I do, I think these 2's will cancel.
Yeah, you will.
You got 2 raised to a what, 7 is it? And they become the negative to a positive 7? Is that equivalent to 2 raised to the 7? Is that statement now true?
Yeah.
If I rewrite each side in terms of the same base. So here I'm gonna show you some examples of what's gonna happen here. Whew. Okay. Are you guys logarithms? We sort of got an idea. Look at this in the green. Right now, just focus on this. I'll give you the hard one to think about. This, all these in the green are saying the same thing that you guys have for years. When you're a teacher back in elementary program now, said 3 raised to the 0, you quickly said 1. This is the way you responded in the red. Now all of a sudden, here you responded like that. Now you think about 3 raised to the 0 is equal to 1 in log form. Here's us, and here's across the street at the middle school. Middle school, us. Middle school, us. We're just rewriting something in a form called logs. That's all we're doing. Okay? Sarah, beautiful question. She said, Professor, when these things get tougher, is there a system that maybe I can rewrite something to lead to the answer? And there it is. So I'll show you what it looks like. Okay? Shortly coming up. Guys, are we okay with this? Sort of leading into logs? You say, Professor, why'd you do this? Because back here, I didn't finish this problem up. I didn't solve for x. I couldn't solve this equation for x. Now, can someone tell me at this point, if I really want to get x by itself, I'll tell you, you cannot solve it from middle school. You're not going to subtract something from both sides. You're not going to divide both sides by something. Not going to do that. Anyone tell me now what this, and I'll be so pleased if you can, what does this, where we stop, look like written in log form?
Log base
Hang on. Log, Lisa, log base what?
E
Thank you. Any more?
of x of no, that's
Log base
2
Two.
equals negative x
Plus one?
plus 1, yeah.
She's exactly right. That's what it looks like. That's what this in the blue now looks like for us tonight. We put it in log form. Now, can I get the x by itself now? It's going to look strange. I can move the 1 over. I'll write mine like this, guys. Log base e of 2 is equal to negative x. Let's move that 1 over. Divide both sides by negative, do some sign changes. And I could end up with this real quickly if I have no mistake. This log base e of 2 is equal to x. Lisa? I think you said I could do that.
Yeah, you could.
Well, I think you said that. I think you're good. All right. I think I didn't make any mistakes in my signs. You guys, are we okay there?
Yeah.
No.
Now, whoa. Now, since that E, that special number came up, as you take higher math, going to math 7, math 8, grad school and so forth and so on, it comes up so often, Mr. Park can agree with this, they abbreviate it, if it's base E, they abbreviate it differently. They don't use the abbreviation LOG. They call it LN, another abbreviation for the word logarithm. So they're gonna write this as 1 subtract now, LN of 2 is equal to X. And there is X all by itself. So guys, if you see the LN notation, it's understood to be a base E. You don't want to put the subscript down there. It's understood to be a subscript of base E. Or natural, and actually they call it a natural log.
Why is it called natural?
It's just one that they come up with or work with so often. In the higher math especially, they call it a natural log. They just use it naturally. For some reason. And they have a history of why E is so much better to use as a base. Okay, but call it natural log. Mr. Park, do me one more favor. Would you estimate this for me, negative ln of 2? I want to see what that is.
Negative 0.69.
Was it right here, the last time you told me, was it a negative? ln of 2.
You mean just ln of 2? Or
Yeah.
negative ln of 2?
Or did I do something out here? Oh, 1 minus ln of 2.
Oh.
Sorry about that. I didn't see my 1 out there.
0.3.
Isn't that the same as you gave me earlier?
Yeah.
As the x-intercept, 0.3? And there's 0.3 for an approximation for that. Get ready. Some of my students are saying, oh, Professor, my goodness, I'm teaching a winter class. I checked today, my class is full. I've got 45 students already for winter. Oh, so we're going to have to get through this. I don't have room, I don't have any space in the winter class. Let's wait till spring. Okay, guys, it makes sense so far with what we're doing.
Yeah.
Okay, especially with that log base E is, will be now identified as ln. Guys, with all that said, this is what it comes down to. And we'll see how much time we got here. Got 5 minutes? Gotta show you what it all comes down to. Now, I know I've thrown a lot at you. Let's call this part 3, I guess, yes. Properties of exponents. I've got more to say after the break, but let's get at least this out of the way. Properties of exponents. Now think about exponents, logarithms. Exponents, logarithms. Now let's travel across the street to the middle school and remind me what this property meant to do. These are like exponentials. A raised to the m times A raised to the n. What did you do back in middle school? If that happened, there was a property that allowed you to do something here. Sarah?
A to the power of m plus n.
You add the exponents. So if you have a product, you add the exponents. Now, I associate the word exponent with logarithms. So now I like to write a property of logarithms directly beneath this, and in essence really means saying the same thing. Now your textbook chose to write what she just gave me like this, and they call it the product property. Came from middle school though, but it's going to look a little different. Product property. And they write it like this. Log some base A, of a product. They identify the product as m times n Can anyone tell me, based on the, what you did back in middle school, what do you think we're allowed to do here for a property? The log of a product should be this what? What happened in middle school? What did I do with the exponents up here? And these are exponents, I add them. That means I can now rewrite this as log base A m plus log base A n. And they identify that as the product property. And I'm sure you've seen this somewhere. Number 2, call this number 1. There's 3 properties, and we're gonna take a break. There's a quotient property for exponents, middle school. Guys, I'm write like this. Go back to my black marker. In middle school, you saw it like this. A raised to the m being divided by quotient. A raised to the n. Who recalls what were you allowed to do with the exponents in a case like that? You subtract them. A raised to the, from middle school, m minus n. Now, since I'm associating exponent with the word log, your textbook rewrites that as, for the quotient property, as this. Blue. Quotient property. Log base A of a quotient, m divided by n, is equivalent to log base A m subtract log base A n. You're doing the same thing, m minus n, m minus n. Except now you're making it look better. We're using logs now. So they call that the quotient property. Looks much like the black one there from middle school. And the last one, and you guys probably remember this one from middle school, the last one they call the power property for exponents. And guys, this one was written back to your middle school as A, some base, raised to the m, all of a sudden, raised further to the n. Okay, want to tell me, what did you do back in middle school in a case like that?
Multiply.
You multiply the two together, the two exponents. A raised to the product, mn. Now, how does your textbook rewrite this for us in Math 2? They call it the power property. They rewrite it like this. I'm using the way your textbook did it. Log, I'll put it on the side here. Log base A of m raised to, they chose to use an r for the exponent, I'll use r, can be written as r log base A m. And they identified that as the power property. Now, are they really doing the same thing we did in middle school? Are they multiplying these two together? Well, there's the exponent here. And by the way, guys, is the log itself another exponent? So in essence, are we actually multiplying two exponents together? This exponent, r, and then the log itself represents an exponent. So I'm multiplying the two together. And that's what you did back in middle school. Sophia,
Where did the n go?
what's that now?
Because we had n, n. Now we only have n.
Oh, beautiful, beautiful. Now, I would have, I did what your textbook did. I probably would have placed an N here and used an N rather than an R. Your textbook, for some reason, uses an R.
Right,
You could use an N.
yeah. I know.
Guys, make sense?
Yeah.
Now, those 3 properties will help me. Now, hang on, I know it's almost time for a break. Will be a big, big help in closing down chapter 4 here shortly. I know, hang on, I'm not going to do too much with it. Those are my 3 properties from middle school rewritten for us in log form. Before I take questions, can anyone tell me right quickly, if you had to find this, log of 20. You said, Professor, what base is it? You didn't use ln, and obviously you had a little subscript there. What base you talking about, Professor? If it's not written, it's understood to be a base 10. So log base 10 of 20. translated, it says, you're trying to find this. 10 raised to some exponent will give you 20. That's what it means. And it's certainly not 2, because 10 squared is 100. But that's what it means. You've got to find 10 raised to something to give you a 20. I know 10 raised to the first is 10. 10 squared is 100. I'm way over. So my answer is caught between what? 1 and 2? 10 raised to the first is 10. 10 squared is 100. I'm looking for 20. That 20 is caught between, right? So my answer is caught between 1 and 2. So it's 1 point something. You wouldn't be able to do it unless you used a calculator. But what I'm going to do before we take a break, can anyone tell me another way, not necessarily the answer, another way to express log of 20 base 10 by using one of these properties?
Use the power property.
Hang on now. Okay, now what power means you will have an exponent. So are you going to rewrite 20 with an exponent? Like what?
So like the log base of 10, so to the of 20 power of x, right? Like,
Wait. Hang on. So you would be saying this up here. Right.
I thought like.
I want you to use one of those properties. And then we'll take a
Oh,
break.
no, it's not the.
Let's say you're really desperate and say, Professor, I have no idea. And we want to write it a little differently on this. But I sat in classes where I just get a look like, whoa. Okay, that's one way to express it. LOG, I'll not put the base, that should be base 10. You could say, Professor, can I write like this? That's 20.
So it's product.
Now, you've written it, so now you should be able to use the product rule. You've written it as a product. And therefore, you can rewrite this right quickly now as log of what? 4
4,
plus
4, 5.
log of 5. And that may help you in some of these problems to rewrite with the help of the properties. Like I used the product property on this one. Now give me, before I take a break, can anyone give me a quotient that I can use for 20? I used a product.
That would be a log
Hang on now, log. Give me more.
4 to the power of x.
I want a quotient. Something divided by something will give me a 20.
10 and 2. Sorry. No.
Not
20
10,
and
that's
2.
5.
20 and 2.
Give me one. A quotient that will give you a 20, and then I'll apply the quotient property. I used the product, I used 4 and 5, now I want a quotient. 40 divided by
2.
2? Lots of possibilities. Now if you have written as a quotient, which I do now, you can rewrite this quotient property.
It would be log 40 minus log 100.
Log 10, 40, I'm sorry, 40, subtract,
Log 2.
you got it. Absolutely. I know it's time for a break. Last one, since I got the clever students in here. Can anyone tell me for the last one, boy, that may be tougher, a way to express this not as a product, 4 or 5, I use 4 times 5, not as a quotient, 40 divided by 2, but a power.
20 to the 0.
Again,
20 to the power of 0.
well, 20 raised to the power of 0 is 1.
Oh, it's 1? Oh. Or to the 1.
The tougher one's a power. Can someone give me one expressed as a power? And then I'll apply the power property.
20 to the first.
We've already done product, quotient, now 20 for power.
Maybe like reciprocal power.
Don't say reciprocal power, don't say them together. Give me a power. Ooh. Something raised to a power.
To
Okay,
equal 20.
here we go.
Something raised to a power.
Yeah, I
is
want
equal
something
20.
raised to a power, you give me a 20.
So 20 to the first.
Oh, 20 to the first, that's 20, that's the
That's
optimal.
20.
I'm not gonna use that because that's just 20. That's
we
just,
would- Oh, okay.
I want something more challenging. Which is true though.
Yeah.
Whoa, hang on, get close.
2 root 5. I don't know.
What's the square root of 400?
It's 20.
20.
400.
20 times 20. Isn't that 400?
400 to the.
Oh, wait, yeah. And this could be expressed as this.
1/2. Oh, yeah, so that's.
Now, is that a power?
Yeah.
And that's inside of that form, now I'm gonna apply this power property. And therefore it says, bring the 1/2 out front,
So 1/2
log
400.
400. Just stop there. At least I could express it like that by using this property. Ooh, I have no idea what log of 400 myself is. I'd have to use a calculator like Mr. Park would have to use something to find log of 400. I have no idea what it is. I could sort of guess, but I don't know exactly what it is. Right, Mr. Park? Okay. Guys, we're okay with this? So that sort of gives you a sense of how chapter 4 is going to start closing down pretty soon. I may get a chance tonight to start the unit circle, the trig. Yes?
So why is it that in some instances we have a base when dealing with log and in these more recent examples?
Okay, beautiful. No, if the base is missing, that's the reason I did not place a base on some of these. It's understood to be a 10.
It's just
Automatically. They call it a common logarithm, base 10. If you see LN,
Then it's E.
it's E for sure. It's not gonna be written for it, but it's understood to be an E if you see LN. LOG, base is missing, it's gonna be a 10. Common logarithm. Guys, thank you for giving me a little extra time to get all this done, which I think we should appreciate after we get back from the break. Usually the break is what, 10 minutes?
Yeah.
Unless
Okay,
it is.
so I'm looking at about 10 minutes off.
You gotta incorporate daylight savings though.
Oh, yeah, an hour, 10 minutes.
If you guys can write me a nice formula with a log in it,
Just add it in.
and you give me some more, I'll give you some more time for your break. If you come up with
Oh,
a
give us
beautiful
a problem.
log problem, no, you guys give me.
Oh,
Okay, guys, take a break.
oh.
I'll see you in 10 minutes.